Hello and welcome to Math Lessons by Chesney. In this lesson, we're going to be learning about coterminal angles around a unit circle. All right, let's get started. So, a coterminal angle is when you're trying to find two angles that have the same value or location on a circle, even though they have different values. We can do this in both degrees and radians. For example, in this circle, it is labeled with various degree measurements around the outside of the circle. This circle has a radius of 1, and certain points are labeled 0, 30, 45, 60, and so on to give us a frame of reference around our circle. If we want to say that this angle, say the angle from center to 60 degrees, has a 60-degree angle, that would be accurate. From our starting place, or from 0 degrees, we would travel counterclockwise 60 degrees to get to this point on the outside of the circle. However, it's not the only way to get to that point of the circle. We could also, of course, travel completely around the circle and end up right back here. If we were to do that, we would not have traveled 60 degrees, we would have traveled 360 degrees, in other words, an entire circle, and then traveled an additional 60. So 360 plus 60 is equal to 420 degrees. In this way, 420 degrees and 60 degrees are considered coterminal. Both measurements give us the same value. Likewise, we could always travel backwards around a circle, in other words, clockwise. So if I was to start from my measure of 0 and go backwards around my circle, I would not be traveling 60 degrees. I would instead be traveling a grand total of 300 degrees, but in the negative direction. In other words, negative 300 degrees. This is because I would have to travel 90 for every quadrant that I pass. So 90 takes me to here, this point. Another 90 takes me here, so now I'm at 180. A third 90 gives me to 270. And then this is 30 degrees from here to here, which is called a reference angle. And so if I'm 30 degrees past this mark, I must be at negative 300, because that would be negative 270. All right, let's take a look at another example. If I was to, say, try to find a coterminal angle for 150 degrees. Well, of course, I know that just traveling from 0 to 150 will get me 150 degrees. So that's one possibility. But if I was to go in the opposite direction, how far would I travel from 0 clockwise to get to 150? Go ahead and think about it. Well, if I'm traveling clockwise, that means I'm going in the negative direction. So my answer is going to be negative. I'll travel 180 degrees to get to here, and then I'll have to travel an additional 30. So I'll have to travel negative 210 degrees. Likewise, of course, I could travel all the way around the circle, and then again to 150, which would be 360 plus 150, which would give me 510 degrees. All three of these angles are considered coterminal. All right. Now this is if you have degrees. Sometimes we are working with radians instead of degrees. In that case, this is the circle that we would be looking at. Now it's the same situation, but instead of each degree measure, I've replaced the degrees with radian measures. If you haven't watched my video on how to convert degrees to radians, please watch that before you begin this second half of this lesson. Now, just as we talked about before, if I wanted to travel to, say, pi over 3 from 0, I could say that that end point is pi over 3. But it doesn't just have to be pi over 3. If I was to travel instead, not to here, but all the way around my circle and then back to this angle, I would have traveled 2 pi, because one full rotation around the circle is 2 pi. I would have traveled 2 pi plus an additional pi over 3. Well, 2 pi as a fraction in thirds is 6 over 3. So 6 over 3 plus 1 over 3 is 7 pi over 3. In other words, 7 pi over 3 and pi over 3 are coterminal radian measurements. Of course, I don't have to go in the counterclockwise direction. I can always go in the negative direction. So if I was to start at 0 and instead go counterclockwise or clockwise around my circle to end up at this same location, I would have traveled half a pi to this first measure, a whole pi to the second one, because I'm basically traveling half a pi each quadrant. Then I'm traveling 3 pi over 2 to get to here, and then finally to get to this last mark, we can always look down at this bottom for a corresponding angle. It's 5 pi over 3. I know that I would have had to travel negative 5 pi over 3 because I'm going in the clockwise direction and it's always negative. So pi over 3, 7 pi over 3, and negative 5 pi over 3 are all considered coterminal radian measurements. All right, let's do one more example. If, for example, I was trying to get to 5 pi over 6. Well, I could of course go from 0 to 5 pi over 6 just by going 5 pi over 6. But if I went the other way, the negative direction, I would travel a full pi and then an additional 1/6 pi, which means that I would have traveled a negative 7 pi over 6. Remember, you can always look at the opposite section of the circle for an easier answer. My 7 pi over 6 is down here. So I know that I would have to go half the circle plus a little more. In other words, 7 pi over 6 radians. Now, of course, that's not the only coterminal angle. There's many. I can travel around the circle as many times as I want. But let's go in the positive direction, in other words, counterclockwise from 0. But this time we'll travel all the way around the circle once, giving us 2 pi, and then travel pi over 6. So 2 pi plus 5 pi over 6, if I wanted to add those together to find another coterminal angle, I would first have to change this 2 pi into a common denominator fraction. In other words, I would have 12 pi over 6 plus 5 pi over 6, which gives me a grand total of 17 pi over 6. And that is a coterminal radian measurement with 5 pi over 6. So anytime you're looking for a coterminal radian, you basically just add 2 pi or 12 pi over 6 repeatedly as many times as you want. Or you can, of course, go in the negative direction. All right, I hope you found this lesson helpful. If you did, please click the like button. If you have any questions, please add them to my comments section or feel free to email me. Thanks and have a great day.